Hello, welcome to a mini lecture about how to use the skein relation. This is based on example 6.3 and 6.5 in the notes and a bit more. So, remember, what did the skein relation tell us? The skein relation is this file looking equation right here. Apparently my rectangle drawing wasn't good enough. It's this relation here. What it does is it tells us that there's a relation between the Jones polynomial of something called L plus, the Jones polynomial of something called L minus, the Jones polynomial of something called L0, where L plus, L minus, and L0 are links that have a diagram that's the same, except in a little bit, where in that little bit in L plus you get a positive crossing, in that little bit in L minus you get a negative crossing, and in that little bit in L0 you get no crossing at all. And there's only one way, well, you know very well how to distinguish a positive crossing from a negative crossing. How do you take a crossing and smooth it out? Well, your link was oriented, so there's only one way to smooth it out that's compatible with the orientations still. Okay, so let's see how to apply it. And the lesson is that you can use the skein relation to work out any one of these three Jones polynomials in terms of the other two. Okay, so let's have a go at the Hopf-Link here. Is this going to be a rectangle? No. No rectangles at all. Okay, let's work out the Jones polynomial of this here Hopf-Link. So how will we decide whether to make this an L plus or an L minus or an L0? Well, the simplest thing to do, and it's not always the correct thing to do, but it's a simple thing, is to pick a crossing like this one and work out whether it's positive or negative, or work out whether it's positive or negative. Well, this is a positive crossing, right? I hope you can see that. So let's take this, the original, to be our L plus. What then do we get for L minus and L0? Well, for L minus, we should take the existing positive crossing and change it into a negative crossing. So that's easily done. There we go. And for L0, we should take the existing positive crossing and smooth it out in the only way that's compatible with the orientations, which gives us this here. Okay, so what's going on? What are L minus and L0? Remember, L plus is the thing we started with, so that's good. Well, L minus, that's just the distant union of two unknots. It's the trivial link with two components. And L0, well, can you see that that's the unknot? And we already know the Jones polynomial of these two things. The Jones polynomial of the unknot is 1, and the Jones polynomial of the trivial link with two components, that's minus t to the half, minus t to the minus a half. Okay, so now we've got our skein relation. What does it tell us? Well, L plus, that was the thing we were interested in already. So let's do that. There we go. What is L minus? L minus is the trivial link with two components, and we know it's Jones polynomial. We worked it out in the previous video. Minus t to the minus 1/2 minus t to the 1/2. And what is L0? Well, it's the unknot. The Jones polynomial of the unknot is 1. So I can just do that. Okay. So now, let's see what this can tell us. Well, why don't I multiply through by t? So I get rid of my t inverse. This becomes a t squared, and this becomes a t out front there. So I get, so let's keep going. I get plus t to the 3/2, that's 2 minus 1/2, plus t to the 5 over 2. That's 2 plus a half. Okay, so that's what that term becomes. And here I get t to the 1 half, that's t to the 1 minus a half, and t to the 3 over 2, which is t times t to the 1 half. And my 3 over 2's cancel out. So what I end up with, rearranging, is that the Jones polynomial of this particular Hopf-Link is equal to minus t to the 5 over 2 minus t to the 1 over 2. Okay, that was just me rearranging. Is that what's in the notes? Double check. Yes, hurrah. Okay, so that's the answer. We've worked out the Jones polynomial of the Hopf-Link. Okay, next example. It's the trefoil. So, what should we do? Let's do what I said was the stupid thing. It's often a good choice. Pick a crossing, work out what kind of crossing it is, and let that dictate what you choose for L plus or L minus. Well, this crossing, what's its sign? It's positive. Oh, let's undo all of that. Okay, so that was a positive crossing. So let's take it, our original link, to be our L plus. And let's draw the wee arrows back in again just for the sake of helpfulness. Okay, so if that was our L plus, what will L minus be? Well, it's what I get by replacing the positive crossing with a negative one, which is there. And then what will L0 be? It's what I get by replacing the positive crossing with no crossing at all, which is there. That's compatible with the orientation. Okay, so actually let's work out what our new L minus and our new L0 are. Well, can you see what L minus is? It's the unknot. And can you see what L0 is? Let's put the rest of the orientation on. So we could have put an arrow there, which would have then ended up there. Can you see what it is? It's the Hopf-Link we had before. Take great care to make sure that the orientations are correct. Okay, so what does the skein relation tell us in this case? Let's take a new copy. Well, L plus was the thing we were interested in. The trefoil. So let's put that in there. Okay. And what was L minus? L minus was the unknot. So its Jones polynomial was, well, let's leave this, whoops, redo, good. Let's just put an unknot in there. And what was L0? L0 was the Hopf-Link. So let's put the Hopf-Link in there. Okay. So we start with the skein relation in general. We then work out exactly which links are the links in our skein relation. And now we can substitute values. So Jones polynomial of the unknot is 1. There you go. I substituted 1. And the Jones polynomial of the Hopf-Link, we just worked that out. That was minus t to the 5 over 2 minus t to the 1 over 2. Okay, so let's keep going. Let's work out this product. I get minus t to the 5 over 2 minus 1 over 2, that's 4 over 2, which is 2. And then next I get minus t to the 1 half minus 1 half, which is minus 1. Then I get plus t to the 5 over 2 plus 1 over 2, so that's plus t cubed, and then I get, finally, plus t. So that was that term there. And my t's cancel. And so let's rearrange this to get the final answer. Well, if I move my equals, well, let's get rid of the things we cancelled. Let's move everything here over to the right, changing the sign. So the minus becomes a plus, that minus becomes a plus, and that plus becomes a minus. And then let's times through by t to get rid of that. So this is a 3, this is a t, and this is a 4. Okay, so that's really minus t to the 4 plus t cubed plus t. Is that correct? Yes, it's correct. Okay, let's take a little pause because we've worked out the Jones polynomial of the Hopf-Link. It's here. And we've worked out the Jones polynomial of the trefoil. It's here. And we worked out the Jones polynomial of the trivial link with two components. That was t to the minus half minus t to the half. So what you should have noticed by now is that the right-hand sides of our computations, the outcomes, they're not terribly pleasant looking. So what I'd like you to do, just have a think about, is can you see any sense in the answers? Is there any property of the link that you can see reflected in the Jones polynomial? Just ask yourself, have a think about it. Okay, so that is the end of this mini lecture.